today we will talk about writing subsystems. I know last week we kind of covered like the overall structure of it, but obviously the most important part of the entire robot code is the actual subsystem code. And so I'm just gonna like talk about them way down and also like walk through the paneler, I think mainly, because that's probably one of the simplest subsystems we had this year, just to kind of give an idea of how you should do this. And I think a lot of this is going to be review based on what we did before, but hopefully it helps to just kind of see it again, especially now that we talked about the overall code structure. So uh, if we remember like the packages from last time, the subsystems are located in a package called subsystems. Surprise! You want to keep the name of the class based on the physical subsystem that it represents so that it's easy to like know what you're talking about. So by the point when you're writing a subsystem, you should have talked about the robot enough that you know what the subsystem will be. Um, each class should be extending the subsystem class. And basically what that does is subsystem is an abstract class, and abstract classes give you kind of an overall framework for what should be included in a class. So the subsystem class, when you extend it, it'll give you a bunch of errors saying that you're missing methods. And so you can automatically have it import all the methods that you need, which will tell you exactly what kind of like methods your code needs to be following and kind of give you an idea for the framework of it. And it helps to keep everything consistent and make sure that like the overall code that's being run can kind of like everything has the same name and stuff so that we can easily call the methods in each subsystem. So there's a bunch of different parts. We start with the variables. Then there's like the looping section, which is what gets called with every iteration in the robot. We have the internal functions and the external functions, which I'll go more in depth about. And then the configuration section, as well as the reset section. So we start with the variables, which are normally right at the top of the class. They include variables for mainly all the devices, so like all the motors or the pneumatics, like the pistons, or rather solenoids. So each motor, each solenoid, and any sensors are normally what you're going to have as your variables. And also if there's any other random variables that need to be associated with that. I guess say for example here, but for the paneler you would have the uh, the solenoid that controls the piston that pushes it up and down, and then you'd also have the talon associated with the motor that's spinning the wheel, and you would have the color sensor. Next is the loop section, which contains the update method, which will first check the superstructure system state and then check the superstructure mode. And so it's just basically a bunch of if statements, which is checking like what status the robot is currently in, and then based on that, it'll say what to do. So as this like example code here shows, if we're in manual or automatic mode, then we can go into checking the superstructure different modes. So if we're in mode 1, which is paneler deploy, then we're going to do certain actions and make sure that the piston is set to up position, but make sure the motor is still off. And then next we'll check if we're in the rotation control mode. So then if that's the case, then we want to check if we should be spinning at that point and so on. So just a bunch of inside the loop to make sure that you've hit everything. And the most important thing here, I think, for safety is that you have the else. So if you're not in manual or automatic mode, then you need to make sure that you've manually stopped everything, because otherwise when you exit from the looping part or like one of the manual mode or whatever, like you disable it or something, the motors don't automatically turn off. So you want to make sure that you put that in and they actually stop when you want them to. Yeah, here's the code. So we have if our system state is manual or automatic, then we can check if we're in the deploying mode, and we'll have all the code here for deploying. Then we have another else if, and we're checking the mode again to see if it's in paneling mode. And then even within paneling mode, we're checking, remember how we had the two different panel states? So within the paneling mode, if we're in rotation, we have one set of code, but if we're in position, we have the else for another set of code, and so on. So it's kind of it's basically as simple as a bunch of if statements checking what mode we're in. Next is internal functions, which are classified as things that should only be accessed within the subsystem itself. And I think the best way to kind of denote that is to say that it would be bad if it's accidentally called from something else. So things like motor speed, moving pistons, resetting encoders, things that you generally don't want to give control of outside of the limited scope of the actual subsystem. So within the paneler, we have things like set piston, which sets the value of the piston, which pushes the system up and down. We have our various motor controlling ones, such as setting percent output to set a speed. We have stop, which will shut the motor down. We have the sensor one, which is reading the color. We have a reset encoder, and we have read FMS, which will read in the message to see what color we need to set it to. So again, just a bunch of functions which do the actual kind of translating from what the code says to what the robot's actually doing, things that we don't want outside subsystems to be able to access and change. But if we do have things that we want other subsystems to be able to read, we would put them under external functions. So again, things that don't really matter from outside. And normally that means it isn't changing anything. It's just a read-only kind of function. So things like this current state of the subsystem, like what its position is or what stage it's in. Like for the control panel, if you have like get what state it's in, and so you can see like, is it finished? That's not going to make a difference in the actual robot, like if something else calls that function. Same thing with get panel rotations. An outside system can read and see how many rotations we've completed, but it can't set, which is why this is an external function and not an internal function. We have questions. Waiting for confirmation from the chat. Okay, cool. Next is the config stuff, which is just kind of like configuring everything. So you'll be creating new objects for every electronic variables. We said like we'll create a variable for each like device, but we want to make sure that we have like we initialize them all within the init function, which is actually the first thing that gets called when the code turns on, which is why we don't want to do it before, like outside of the init function. If you initialize the device outside, then I think it like messes things up. So you want to make sure you create the device outside. It's a little complicated. We have to make the variable for the device outside of any functions, but inside the init function, you want to initialize every device. And you'll do that with the numbers from ports.java, as Liam talked about last week. And you can also use this part to reset and set the settings on things like resetting encoders or sensors, putting them back to 0 to make sure that everything is as you need. So here's another snippet from the paneler. So we already made the sensor, piston, and motor. Oh, we hear you, Jack. Okay. So before like in the very first part of this class, we've already made a sensor, a new sensor, a new piston, and a new motor. And so here in the actual init function is where we're actually initializing the object by saying make it a new color sensor using the port numbers that we've set in this function or in this class. And then we're also doing things like resetting it. So putting the motor back to factory default, resetting the encoder, setting the deadband, and all this stuff, which you don't really need to know. But just know that if you have to do something like that, it's over here. Okay, next is the superstructure code. So the superstructure reads from the subsystem itself, and then based on that, it can change its mode or based on controller output. So another way to think about the superstructure is just kind of like the middleman, like controlling each subsystem and kind of figuring out what the robot needs to be doing at that point. So for example, the superstructure will be setting the mode to paneling. And so within the paneler, we will be looking and checking if we're in the panel, like what we'll be doing. But also within the superstructure, it will be checking to like reading from the paneler, so the is finished method. And if the paneler says, yeah, I've finished whatever I'm supposed to do, then the superstructure is the one which sets the robot back to idling, not the paneler itself. So the superstructure is kind of like the master thing that can control everything underneath it. And it'll be reading in these external functions from the subsystem. Yeah, and it also just kind of helps to make sure you're not setting like multiple modes. Like if you're in paneler, you don't want to be like shooting at the same time. But if they're written separately from each other and they're both trying to set the modes for like each other, they can conflict because they're not really like connected. But the superstructure kind of keeps everything in one place and um, make sure that like each subsystem is doing what it's supposed to. Next is the teleop controller, which reads from the Xbox controller and sets the modes and superstructure. So again, it looks like a pretty complicated file. I think we looked at it last week, but it's just a whole bunch of if statements. It checks if a certain control is pressed. So in this case, if the panel deploy code is pressed, then if it'll just check what mode you're in and switch it. So if you're in paneling mode currently, it'll uh, change it to deploying, but if you're in deploying, it'll change it to paneling. That was confusing. But yeah, it just checks what mode you're in and then either sets it back to idle or sets it to like deploying based on what state you're currently in and if you press the button. Okay. Sorry, that was kind of confusing. Any questions? All right. I think, is that it? Yeah, that's all I have for today.